There is this really universal experience in online multiplayer gaming. You're having just the absolute run of your life, right?
Yeah.
Everything is clicking, your reflexes are totally on point, and then you finally check the global leaderboard, and sitting right there at number 1 is a player named, like, Guess 123 with a score of 9 billion.
Right, yeah. A score that, mathematically defies the actual laws of physics programmed into the game itself.
Exactly. And you just know they cheated.
Yeah.
But proving it, that is the notoriously hard part. I mean, game studios spend millions on anti-cheat software, and it always just turns into this endless, exhausting game of whack-a-mole.
It really does.
Like the studio patches a vulnerability, and then the hackers devise a new exploit an hour later. And it's usually the legitimate players who get caught in the crossfire.
Well, yeah, because it's a centralized arms race,
Yeah.
The studio's back-end servers are just desperately trying to catch the hackers while the hackers are out there spoofing the servers to make their impossible data look completely legitimate.
Right.
The architecture itself is kind of the core problem.
Yeah. Well, welcome to another deep dive. Today, we are looking at a system that attempts to completely flip that arms race on its head. We're diving into Materios.
Yes.
Now, just to establish the technical baseline for you, Materios is a substrate-based partner chain on the Cardano network. And it's basically trying to solve a massive blockchain bottleneck.
Which is the struggle of getting fast, cheap, provable data validated without just instantly clogging up a major layer 1 network.
Exactly. And we have a huge stack of sources today to guide us through this. We are pulling from FluxPoint Studios' technical documentation, their operator guides, the mainnet roadmaps, and their highly detailed and honestly surprisingly dramatic East-Metrio token merger FAQ.
Oh, the drama is real in that one.
It really is. So our mission for this deep dive is to explore how Materios acts as a decentralized anti-cheat engine. And then we are going to navigate the incredibly complex, sometimes painful tokenomics of launching a brand new decentralized economy.
Because building the underlying technology is really only half the battle. Funding that tech and managing a massive ecosystem transition without, alienating your earliest supporters, that is where the theoretical meets the harsh reality of the market.
Okay, let's unpack this. We need to start with the core problem Materios is actually trying to solve here. Because blockchains, as you and I know them, are fantastic for ultimate security, right?
Oh, absolutely.
They're great at moving money around trustlessly. But they are absolutely terrible for processing fast, high-volume data streams, like video game telemetry.
Right. I mean, consider the data footprint of a modern video game. It generates data every fraction of a second.
Yeah.
The system is tracking, where your character is standing, the trajectory of your movement, your ammo count, your health regeneration.
It's an insane amount of data.
It is. And if a developer attempted to write all of that telemetry directly to a layer 1 blockchain like Cardano in real time, the transaction fees would literally bankrupt the game studio within an hour. And, well, the sheer volume of data would just force the network to grind to a halt. Blockchains simply were not built to process that kind of noise.
So the developer has a dilemma. How do you mathematically prove to the world that a player's high score is real without, hitting the mainnet for every single jump, shot, or movement?
So Materios approaches this bottleneck with a concept they call a blob gateway.
A blob gateway. Okay, it sounds vaguely sci-fi, but I'm assuming it's heavily grounded in standard web architecture.
Very much so. It's highly practical. Basically, when a player finishes a run in a game, the game client gathers all that telemetry data, the duration of the run, the score, the inputs, and packages it into a JSON file.
Right, and just for context, the JSON file is just a universal lightweight text format, right? Computers use it to easily exchange data.
Exactly. It looks a bit like a stripped-down digital spreadsheet, so that file is the blob.
Okay, got it.
The client uploads that heavy text file to the off-chain Materios gateway. Then it takes a tiny, lightweight cryptographic receipt pointing to that data and submits only that receipt to the Materios chain.
I see. So the heavy, cumbersome data sits off-chain where, storage is cheap, but the irrefutable proof that the data exists goes on-chain.
Precisely.
Well, wait. How do we know the data inside that JSON file isn't just entirely fabricated? Like, how does this actually catch our friend Guess 123 and their 9 billion points?
Well, the secret lies in the validation schema. The documentation provides a really tangible, real-world example here. There's a game called Clay Monster Dash.
Oh, I love it.
Yeah, which is actually the first game fully integrated with the Materios network.
Who doesn't love a good Monster Dash, right? Let's use it as our test case.
Perfect. So Clay Monster Dash has a strictly defined mathematical framework known as Schema V1, and this is formally registered on the Materios Network. This schema checks the player's uploaded telemetry for physical plausibility based on the game's, coded reality.
Okay, so instead of scanning a player's computer for illicit software, which, let's be honest, is invasive and usually fails anyway, it just looks at the final math. Give me an example of what that actually looks like.
Sure. So the schema checks the total distance the player claims to have traveled, right? And it divides that by the total duration of the run. If the resulting speed is over 30 meters per second, the system just automatically flags it.
Because the physics engine of the game simply doesn't allow a character to run that fast.
Right. It is mathematically impossible. And furthermore, it checks a metric called crystal density. If the telemetry claims you collected more than 0.65 crystals per meter traveled, the math exposes the lie.
That is such an elegant solution. It ignores the method of cheating entirely. Like, it doesn't matter if you used an ambot or a memory editor or altered your network clock.
Exactly.
If the laws of the game universe were broken, the math catches you.
Yep. And once a predetermined threshold of independent network nodes, which they call attesters, look at that blob and independently verify that the math checks out against the schema, the receipt gets certified.
Right.
And the documentation points out a really critical metric here. This entire decentralized certification process happens in roughly 12 seconds.
12 seconds. Wow. 12 seconds for a decentralized network to reach consensus on external data is phenomenally fast.
It is.
But you mentioned earlier that Materios is a partner chain to Cardano. How do those two networks actually communicate with each other?
Well, this is the vital anchoring step. So every 2 minutes or so, the Materios Network gathers a batch of all these newly certified receipts. It bundles them together and compresses them into a single cryptographic hash known as a Merkle root.
Quickly, let me stop you there just to define that quickly, because Merkle root gets thrown around a lot in crypto. Think of a Merkle root like a massive tournament bracket, right?
Yeah, that's a good way to look at it.
You start with thousands of individual pieces of data at the bottom. You pair them off and combine their digital fingerprints over and over, moving up the bracket. And eventually, you're left with just one single unique fingerprint at the very top. That is the Merkle root. If even one tiny piece of data at the bottom is altered, the entire root at the top changes completely.
That is an excellent breakdown. So Materios takes that single fingerprint, that Merkle root representing thousands of game runs, and anchors it to the Cardano mainnet under a specific metadata label, which is 800-7466.
Okay, I have an analogy for how this all fits together.
Let's hear it.
Imagine an incredibly exclusive VIP club. The club owner is Cardano. If the owner had to individually interview and pat down and background check every single guest right at the front door, the line would stretch around the city block.
Oh, easily. It would be agonizingly slow.
Right, and financially ruinous to pay for all that security at the main entrance.
It would completely defeat the purpose of the venue.
Exactly. So instead, Materios steps in to act like a highly efficient team of off-site bouncers. They gather the guests at an off-site location, check everyone's IDs, run the background checks, ensure nobody has a fake ID.
Which represents that mathematical schema check.
Yes. Once they are satisfied, they put all those names onto one single verified clipboard. They walk up to the club owner, hand over that one clipboard, which is the Merkle root, and then they just walk away.
The bouncer analogy captures the architecture perfectly. And what's fascinating here is that because they are only handing over that one clipboard, the cost is microscopic.
How microscopic are we talking?
Well, the technical docs note that anchoring an entire batch of these receipts to Cardano costs roughly 0.18 ADA.
Wow. Which means you are securing video game data with the unbreakable multi-billion-dollar security of the Cardano mainnet. But you're amortizing the cost of that security across thousands of individual player runs.
Exactly. And it creates tamper-proof, publicly auditable leaderboards. But better yet, it requires zero back-end trust from the developers themselves. The studio never has to promise the community that their leaderboards are clean because the decentralized network has already verified the math independently.
Okay, which leads me directly into my next major concern. Because the bouncer analogy really only works if we actually trust the bouncers, right?
Fair point.
We have this decentralized workforce verifying the crystal density in Clay Monster Dash. Who exactly are these people, and how do they get hired for the job?
So the network organizes this workforce using a specialized committee structure, and it's driven by a selection algorithm named Ariadne.
Ariadne. Gotta love keeping with the classic crypto tradition of naming things after Greek mythology.
Indeed. So the Ariadne algorithm utilizes a specific D parameter, which is currently set at 3-2.
Okay, what does that mean?
Well, this parameter dictates the composition of the validator committee. The 3 signifies 3 permissioned validators. These are like enterprise-grade nodes managed by a governance whitelist. Currently, this bucket consists of FluxPoint Studio's internal nodes and a few specifically invited partners to ensure network stability in these early stages.
Okay, so there is a slight centralized guardrail while the network finds its footing. What about the 2 in that parameter?
The 2 represents the permissionless, decentralized side of block production. These seats are open to SPO validators, specifically existing Cardano stake pool operators. They actively compete for those 2 slots. And their probability of being selected by the algorithm is heavily weighted by how much active ADA delegation they have on the Cardano pre-prod network.
That is a very strategic move. It taps directly into Cardano's established ecosystem of node operators, essentially borrowing their hardware expertise.
Exactly.
But wait, we have been using the term validators. Earlier you mentioned attesters. In a lot of networks, those terms are used interchangeably. Are they the same thing here?
No. They serve very different functions in the Materios architecture.
Yeah.
Validators are the heavy lifters that actually produce the blocks and maintain the blockchain. Attesters, on the other hand, are the workers doing the specific granular checks on those JSON blobs. And crucially, the attester role is entirely permissionless.
When you say entirely permissionless, does that mean, like, literally anyone listening to this deep dive right now could become an attester?
Absolutely anyone. The operator guide makes this a major selling point. They have streamlined it down to a one-line installation script available for Mac, Linux, or Windows using Docker containers.
Oh, wow.
But the most surprising aspect is the hardware requirement. To run an attester node, you only need 1 vCPU and 512 megabytes of RAM.
Okay, let's pause on that. 512 megabytes of RAM.
Yeah.
A standard smartwatch has more computing power than that. A basic web browser with 2 tabs open uses more RAM. How is it possible to secure a network on hardware that weak?
It's because of the nature of the task. The attester node is not rendering graphics. It is not storing massive databases. It is simply downloading a text file, plugging a few numbers into a predetermined math formula like dividing distance by duration, and outputting a true or false result.
Oh, I see.
It requires almost zero computational overhead. And as an incentive for doing this lightweight work, attesters currently earn 10 TMA Ture, which is the testnet version of the token, for every single receipt they help certify.
Okay, I have to push back here. Because if anyone with a dust-covered laptop from 2012 can just copy-paste a script, boot up a Docker container, and start verifying game data, how on earth does the network prevent a Sybil attack?
It's a valid question.
Right. Like, what stops a bad actor from spinning up 500 fake attester nodes in a server farm, rubber stamping fake telemetry, and just draining the network of tokens?
Well, the architecture anticipates exactly that scenario, and this brings us to the threshold attestation model. A single attester checking the math is completely meaningless. The network mandates a 2 of 10 threshold.
Let's map that out. How does that actually stop the bad actor?
Okay, when a piece of data comes in, the network randomly assigns a 10-member committee of attesters to review it. Out of those 10, at least 2 fully independent nodes must verify the blob against the schema for it to pass.
Okay.
If a hacker spins up a rogue node and tries to approve a blob where their character is moving 500 meters per second, their single approval goes into the void. The other honest nodes on that random committee will run the same math, see that it wildly fails the physical plausibility check, and reject it. Consensus overrides the rogue node.
Ah, I see. So the math itself acts as the ultimate incorruptible referee. You can social engineer a human, and you can spoof a server, but you cannot spoof basic division.
Exactly. The protocol leverages decentralization not just as a buzzword, but as a genuinely scalable security apparatus.
Okay, so we've established this global decentralized workforce, running nodes in the background, checking the physics of video games, and earning mad tree tokens for their trouble. But if we follow the money, operators getting paid means someone else has to be footing the bill.
The foundational rule of blockchain economics. The energy and security must be compensated.
And this is where we usually run into the classic crypto gaming trap. If you have ever tried to play a Web3 game, you know the absolute friction involved.
Oh, it's terrible.
You are having fun, and suddenly, just to swing a sword or save a high score, a pop-up appears demanding you pay a gas fee in some highly volatile cryptocurrency.
Right.
It completely breaks the immersion. Gamers despise it, and developers hate implementing it right into their user experience. So how does Materios bypass this massive hurdle?
By fundamentally divorcing the asset of speculative value from the asset of operational utility. They utilize a dual token model. The first token is a TRA.
Okay, and if Matra is the investment, the capital asset, then you cannot expect players or developers to constantly sell off their investment just to reload a digital weapon.
Precisely the issue. Matra is the transferable capital token. It has a strict, immutable maximum supply of 1 billion tokens.
Yeah.
It is used to stake, to secure the validators, and to vote in governance. It holds the economic weight. But you do not use it to pay for individual transactions. That is handled by the second token, MOTRA, spelled with an O.
So there must be a separate utility mechanism. How does OTRI function differently?
Well, OMOTR is the network capacity token, and the defining characteristic is that it is entirely non-transferable. You cannot buy OMOTR on an exchange, and you cannot sell it to another player.
Wait, if it cannot be bought or sold, how does a developer acquire it to pay the network fees?
By holding the primary asset, the system automatically generates OMOTR based on your Motrea balance. It continuously drips into your account over time.
Okay.
When you submit a certified receipt to the network, you burn OPRA to process it. Furthermore, if you let your OBTRA sit unused, it actively decays and disappears.
Okay, here's where it gets really interesting. Let me try to visualize this with an analogy.
Go for it.
Imagine you hold an annual pass to an elite theme park. That annual pass is your Maitreya. It is incredibly valuable, and if you ever decide you are done with the park, you can sell that pass to someone else.
Right.
But simply by having that pass sitting in your pocket, it continuously prints out fast pass ride tickets. Those disposable tickets are the EVs.
That aligns perfectly with the economic design.
So you use the ride tickets to get onto the roller coasters, which represents writing data to the Materios chain. If you ride the roller coaster all day, you burn through your tickets. If you stay home for a month, your printed tickets expire and decay. But the vital piece of this puzzle is that you never have to sell off tiny fractions of your actual annual park pass just to get on a ride.
It's an excellent analogy, and if we connect this to the bigger picture, this dual token dynamic neutralizes the friction of user onboarding.
Yep.
A traditional game studio can just hold a treasury of Maitreya. That treasury continuously generates MOTC. The studio then uses that Maitreya to invisibly pay the transaction fees for their player base in the background.
So the player never even knows a blockchain is running under the hood.
Exact.
They don't need a wallet extension, they don't need to buy crypto, they just play the game.
It bridges the gap between traditional gaming infrastructure and decentralized verification without sacrificing the user experience.
That structural design makes a lot of sense. But if everything revolves around this hard cap of 1 billion Emitri tokens, we need to talk about distribution. Because as I read through the documentation, this is not a fresh out-of-the-box launch where they just mint 1 billion tokens and start selling them.
Far from it. The launch requires a massive, incredibly sensitive consolidation of pre-existing assets. The team refers to this as the Kemp-Emitra token merger.
Right, and just to clarify the terminology for you listening, Emitra is the Cardano native transitional token that will eventually bridge over to the Materios mainnet. But the merger document details that they're rolling 7 different legacy Cardano assets into this one new token cap table.
It is a really ambitious undertaking. The merger includes 2 fungible tokens agent and shards, alongside 5 entirely distinct NFT collections, including the FlexPoint Team Pass and SC Brawlers.
Wow.
Yeah, they are attempting to take multiple fragmented communities, each with their own perceived valuations, and collapse them into a single unified economy.
I mean, merging fungible tokens is one thing, but how do you mathematically merge unique NFT art collections into a standard interchangeable token? Do they just, like, take a snapshot of everyone's wallets on a random Tuesday and airdrop the new CPay tray?
Actually, the team explicitly rejected the snapshot model for the public migration.
Oh, really?
Instead, they implemented a strict surrender and redeem model operating over a 6-month window.
So you have to actually part with your old assets.
Yes, you must physically control and burn the old assets to mint the new ones. And this has severe implications for the decentralized finance space.
How so?
Well, if you currently have your legacy agent or shards tokens locked up, providing liquidity on decentralized exchanges like MinSwap or WingRiders, you cannot simply leave them there and expect an airdrop.
Ah, you have to manually intervene. You must unfarm those tokens, pull your liquidity out of the decentralized exchange, transfer everything back to a private wallet, and push them through the official surrender portal.
Which creates an immediate risk. If everyone pulls their liquidity out of the decentralized exchanges at the exact same time to migrate, the trading markets for those legacy tokens would instantly collapse right before the launch.
Total market chaos. How are they preventing a bank run on liquidity?
Through what they call the LP loyalty bonus. The documentation outlines that if you keep your legacy tokens actively providing liquidity in those pools right up until a secret, unannounced pre-launch snapshot, the protocol rewards you with a 3% bonus on your final CMA TRA redemption.
Oh, that's smart. It is a financial incentive designed specifically to keep the market stable during the transition phase.
Exactly. A clever way to maintain order.
It is. But I am looking at the Kenetai FAQ document right now, and I have to challenge something that stands out as highly controversial.
Okay.
In a previous version of this document, the conversion rates were set. Now, the updated text states there is a 15% dilution compared to those previously published rates.
Right.
So someone holding an NFT thought they were getting X amount of tokens, and now they're suddenly getting 15% less. It sounds like the community just had the rug pulled out from under them. So what does this all mean?
It is entirely understandable why the community would view that initial 15% reduction with alarm. It's a shock. However, delving into the rationale provided in the FAQ reveals a case study in painful but necessary transparency.
Okay, I'll unpack that.
The dilution fundamentally revolves around funding the network incentives reserve.
Explain that reserve, because a 15% haircut across the board is massive.
When the team ran the long-term mathematical models on their original published rates, they discovered a fatal flaw. The original rates allocated almost the entirety of the 1 billion supply to the public migration. But if the public holds all the tokens on day one, how does the network pay the validators producing the blocks? How do they compensate the thousands of attesters running those Docker nodes? Where does the liquidity come from to list the token on an exchange?
You would have zero treasury.
Yeah.
The network would stall out immediately.
Okay.
Unless you do what a lot of projects do, and you just quietly alter the code to print more tokens later, inflating the supply beyond the cap.
Okay, exactly. The hidden inflation trap. But Materios opted to confront the math up front. The revised models determined that the network requires exactly 27.75% of the total supply to be locked in reserve to function sustainably over the next decade. That reserve is dedicated to validator emissions, the ecosystem treasury, strategic partnerships, and launch liquidity.
So, to make room for that critical reserve pie, they had to shrink the public allocation pie by 15%.
Yes.
I understand the mechanics of it, but it still feels like the developers are punishing the community to fix their own math error.
That leads to a crucial detail in the FAQ that often gets overlooked in the heat of token controversies. The FlexPoint team applied that exact same 15% reduction to their own allocations.
Wait, really? The founders didn't find a loophole to exempt their own treasuries?
They did not. The documentation details that the team held millions of legacy tokens locked inside on-chain DAO treasuries.
Oh, wow.
And because voter turnout in those DAOs was virtually non-existent, the funds were permanently stranded. To resolve this, the team explicitly waived those stuck balances from the public pool and had the equivalent CMA TRA minted directly to their operational wallets.
And when that mint occurred, they voluntarily took the 15% dilution on those millions of tokens.
They absorbed the hit alongside the public. The documentation frames this as the harsh reality of launching a sustainable blockchain. You either execute the painful math before the network goes live, or you rely on deceptive inflation and slowly bleed the community's value away over the next 5 years.
They chose the upfront pain to preserve the 1 billion hard cap. You know, when you look at the graveyard of crypto projects that inflated themselves to zero, taking the medicine early actually sounds like the responsible, albeit unpopular, choice.
It prioritizes long-term viability over short-term sentiment.
All right, let's zoom out and synthesize this entire architecture. We started with a fundamental problem. Video game anti-cheat is a centralized, expensive, and ultimately losing battle.
Yes.
Materios steps into this gap by offloading the heavy lifting from the Cardano mainnet. They deploy a decentralized army of attesters, everyday people running incredibly lightweight software to verify the mathematical reality of video game telemetry in 12 seconds.
And they neutralize the notorious Web3 gas fee problem by implementing the dual token model, where holding Matra passively generates Moche, allowing developers to process transactions invisibly.
Finally, to fund this ecosystem, they are executing a mathematically strict migration, rolling 7 fragmented legacy assets into one unified economy and absorbing a 15% dilution up front to ensure the network actually has the treasury it needs to survive.
It is a highly pragmatic, deeply considered approach to building decentralized infrastructure.
Whether you are a gamer who's just sick to death of cheaters ruining your runs, or a developer searching for a trustless backend, or just someone who appreciates the intricate mechanics of token economics, Materios is a fascinating case study.
Yeah.
But before we sign off, there is one final lingering detail from the overview document that I really cannot stop thinking about.
Oh, the broader application of the protocol.
Exactly. The documentation explicitly states that Materios is not restricting itself to video games. They are actively extending this proof of inference protocol to verify artificial intelligence.
Auditing AI decision-making.
Think about the massive implications of that. If this decentralized 12-second network of everyday laptops can catch a cheater in Clay Monster Dash simply by auditing the math of their crystal density, what happens when these exact same nodes start verifying the hidden decision-making algorithms of autonomous AI agents executing real, high-stakes financial trades?
It introduces an entirely new layer of accountability. This raises an important question about how we establish trust in an increasingly automated world.
Who's auditing the AI? If Materios scales, the answer might be all of us. Thank you so much for joining us on this deep dive. Take these ideas, turn them over in your mind, and we will catch you on the next one.